Good morning to one and all. My name is Anupama. My register number is 24BQ1A0492. Today, my seminar topic is latches and flip-flops. Let us first we discuss about latches. Latches. What is latches? In digital electronics, a latch is an as- asynchronous sequential circuit that can store one bit information. It is used as a fundamental memory element in the digital circuits. A latch can have two stable states, namely set and reset. The set state is denoted by logic 1 and reset state is represented by logic 0. The most important thing to be noted about latches is that they do not have clock signal for synchronization. That is why they are called asynchronous sequential circuits. The logic gates are the fundamental building blocks of the latches, since there is no synchronous and clock signal used. Hence, the latches operate immediately on the application of the input signal. Characteristics of latches. Some key characteristics of latches are explained below. Latches can store one bit of digital information that can be represented using either logic 0 or logic 1. Thus, the latches are mainly used as a memory elements in digital circuits. Latches have a feedback mechanism that allows them to maintain their current state as it is until the next input is applied. The operation of latches is commonly controlled by the applied input. That means the output of the latches update based on the change in input signals. Types of latches. There are four types of latches, namely SR latch, JK latch, D latch, T latch. Let us now discuss about each type of latch in detail. First we discuss about SR latch. The SR latch is a type of latch which has two input lines designed as S and R, where S represent the state input and R represent the reset input. Thus, it is called as set reset latch. The SR latch has two stable states, namely set state S and reset state R. The block diagram of SR latch is shown in the figure. Here it's below. It is. In the case of SR latch, the S input sets the output Q to 1 and Q bar to 0. On the other hand, the R input set the output Q to 0 and Q bar to 1. In case when both S and R inputs are high, the latch is said to be in forbidden state. The complete operation of HR latch, SR latch for different input combination is described in the following truth table. If both inputs are high, then SR latch is considered as forbidden state and the state is uh, indeterminate. When both the inputs are low, then the output Q is no change. The SRLS can be implemented by connecting two NOR gates in cross-coupled manner as shown in the figure. SR latch is also called as cross-coupled NOR gate latch. The second latch is JK latch. The JK latch is another type of latch which has two inputs, namely J and K. Here the input J is similar to S input and the input K is similar to R input in an SR latch. The operation of JK latch is similar to that of SR latch, but it does not have forbidden state. Instead, it has toggle state, in which the output Q and Q bar swap their state when both the inputs J and K are 1. Therefore, the JK latch is mainly designed to overcome the problem of forbidden state in SR latch. The block diagram of JK latch is shown in the following figure. The truth table given below describes the operation of JK latch for different input combinations. If both the inputs are high, then the output state is known as toggle state. When both the inputs are low, no change in state. From this truth table, it is clear that the problem of forbidden state is addressed by implementing the toggle state. The logic circuit of JK latch consists of combination of two NOR gates and two NAND gates as shown in the following figure. The third latch is T-latch. T-latch is a type of latch that toggles its output state Q when the logic is 1 applied to the input line. Hence, it is also known as toggle latch. The T-latch is implemented by connecting the J and K inputs of JK latch together as shown in the following diagram. The truth table describes the operation of T-latch is shown below. For 0 input, the output is 0. For the output 1, the state is toggle. The logic circuit diagram of T-latch is shown in the following figure. The next latch is D-latch. The D-latch, also known as data latch or transparent latch, is a type of digestible multivariable which has two input signals, namely D input and E enable input. The output Q of D latch is same as the input applied at D input line as long as E input is high. When the E input goes low, the output of D latch is held as it is until the new input is applied to the D input. The block diagram of D latch is shown in the following figure. The truth table given below explains the operation of D-latch. The logic circuit diagram of D-latch is shown in the following figure. Let us discuss about the applications of latches. The latches find several applications in the field of digital electronics. They are most elementary storage components used to store one bit of information in digital system. Some of the common applications of latches are listed here. Latches are used as one bit memory elements in digital system. Latches are used to design registers which are employed for storage and manipulation of data in microprocessing and microcontrollers. Latches are used to design flip-flops which are basically the synchronized latches. Latches are also used in communication system for temporary or buffering purpose. Now let us discuss about the flip-flops. A flip-flop, what is flip-flop? A flip-flop is a sequential digital electronic circuit having two stable states that can be used to store one bit of binary data. Flip-flops are the fundamental building blocks of all memory devices. They are used to create memory elements such as registers and counters and are essential for controlling the state of circuit. Their ability to hold a value until told to change is what makes them indispensable for sequence synchronization, the data storage in modern digital system. Importance of flip-flop. First one, data storage. Flip-flops are the basic unit of memory, storing one bit of data, 0 or 1, until the state is changed by an input or clock signal. Multiple flip-flops can be combined to store large amount of data. The second one is sequential circuits. They are the core of the sequential logic circuits where the output depends on both the current input and the circuit current state, that is the data stored in the flip-flop. Counters. Flip-flops are used to build counters which can count events, measure time or divide frequencies. Registers. The fourth importance of flip-flop is registers and memory. They form the basis of registers and memory units essential for holding temporary data during processing in microprocessors, storage information in computer systems. The next important was synchronization. Their clocked operation ensures that operation occurs at right time, making them visual for synchronizing signals in the circuits and preventing timing error. The next important was control logic. Flip-flops can be used to control the operation of digital circuit, changing its behavior based on the stored data. Digital signal processing, next importance. In DSP, they are used for tasks like data sampling, buffering and synchronizing data streams. Let us discuss about the types of flip-flops. There are four types of flip-flops: SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. First we discuss about SR flip-flop. This is the simplest flip-flop circuit. It has set input and reset input. When in the circuit, when S is as active, the output Q would be high and Q bar will be low. If R is set to active, then the output Q is low and the Q bar is high. Once the output are established, the result of the circuit are maintained until S or R get changed or the power is turned off. The SR flip-flop um, circuit diagram is shown below. The truth table of SR flip-flop: when both the inputs are high, the output is uh, the output was forbidden state or undetermined state. When both the inputs are 0, no change. When S is 0, the state is reset, and when S is 1, the state is set. Characteristics table of SR flip-flop is given above in the table. The characteristic equation of SR flip-flop: Qn plus 1 equals to S plus Q bar into Q of n. Excitation table. The SR flip-flop has invalid state S equals to 1, R equals to 1, which leads to don't care cross condition in its excitation state. Cross don't care means the input can be either 0 or 1. The next flip-flop was JK flip-flop. Because of the invalid state corresponding to S equals to R equals to 1 in the SR flip-flop, there is a need of another flip-flop. The JK flip-flop operates with only positive or negative clock transitions. The operation of JK flip-flop is similar to the SR flip-flop. When the input j and k are different, then the output q takes the value of j at the next clock edge. When j and k both are low, then no change occurs at output. If both j and k are high, then at the clock edge the output will be toggled from one state to another. Circuit diagram of JK flip-flop is shown below. Truth table of JK flip-flop. When both the inputs are high, the output Q is toggle. When both the inputs are 0, the output was no change. Characteristics table of JK flip-flop is given below. The characteristic equation of JK flip-flop Qn plus 1 equals to JK into Q of n bar plus K bar into Q of n. Excitation table of JK flip-flop. The JK flip-flop eliminates the invalid state of SR flip-flop by using J equals to 1, K equals to 1 condition for toggle, which resulting in more don't care conditions in the input column, which is shown in the below. The next flip-flop is T flip-flop. A T flip-flop is a simplified version of JK flip-flop. The T flip-flop is obtained by connecting the J and K input together. The flip-flop has one input terminal and clock input. These flip-flops are said to be T flip-flop because of their ability to toggle the input state. Toggle flip-flops are mostly used in counters. The logic diagram of T flip-flop is given below. Truth table. When the T input is 0, the output was Qn, no change. If T equals to 1, then output is Qn bar toggle state. When T equals to 0, the next state is same as the current state Qn. The flip-flop holds its value. When T equals to 1, the next state is complement of the current state Qn. The flip-flop toggles its value. Therefore, it is known as the toggle flip-flop. Characteristic table of T flip-flop is given below. Characteristic equation Qn plus 1 equals to 3 complement of T XOR Qn, or it is expanded sum of products from Qn plus 1 equals to T into Qn bar plus T bar into Qn. Excitation table of T flip-flop. The T flip-flop is simplified to analysis as it inputs T directly corresponding to whether a change in state is required. The next flip-flop was D flip-flop. In D flip-flop, the output can only be changed at positive or negative clock transitions, and when the input changes at other time, the output will remain unaffected. The D flip-flops are generally used for shift generators and counters. The change in output state of D flip-flop depends upon the active transition of clock. The output Q is same as input and changes only at active transition of clock. Truth table of D flip-flop. When the D input is 0, the output is 0. When the D input is 1, the output will be 1. The uh, characteristic table of D flip-flop is given as shown in the figure. The characteristic equation of D flip-flop is Qn plus 1 equals to D. Excitation table for D flip-flop. The D flip-flop is the most direct as the required input D is simply equal to the desired next state, which is shown as below. Thank you.